Now that we've covered the shape or frequency of the data and the center of the data, let's talk about variability, starting with the range. The range is the spread from the lowest to the highest value in a variable. In other words, it's the difference between the min and the max. So if we look at this data set here from our project and plot all the undergrad grades on this scale here, well then the range represents this length right here, which is simply just 93.6 minus 63.3 or 30.3. That's our range value. So pretty simple stuff. Now, quick call out before we jump to Excel. While the range is generally a good indicator of the total variability in a numerical variable, please be mindful that a single outlier on either side, either the min or the max, can cause the range to change significantly. So let's jump to Excel and see an example. We're going to click on the link on our min, max, and range section. And let's look at the question we have here. How does the total spread of the graduate's employability scores compare before and after the MBA program? Alright, so total spread means the range. So let's start by calculating the min and max values for employability before and after. So let's start with the min function in Excel. Select this range. You'll notice that both of them are the same size, so we can drag our formulas to the right. That's our min before. If we drag over here, you'll see that now we have our min after. Now let's calculate the max. And let's drag this to the right. And the range is simply going to be max minus min. We can drag this to the right as well. And there we have it. So what does this range value tell us? Well, we can see that the employability scores are just a little bit more spread out after the program. And if we look at the min and the max values, then we can see that they are also a little bit higher after the program. Okay, so we know that the range is the total spread of the values, but what's the interquartile range? Well, the interquartile range is the spread of the middle half of the values. In other words, it's the spread from the first quartile, or the 25th percentile, to the third quartile, or 75th percentile. And let me show you exactly what I mean by this with an example. We've got this sorted sample of 16 undergrad grades, so if we were to split it in half, then the value in the middle would be the median. And if we do an additional split so that we have 4 equal pieces, or quartiles, then these values that you see here are the first and the third quartile, with the median also being known as the second quartile. So now each of these sections represents 25% of the data. And if we grab the range of that middle half, the middle 50%, then that's what the interquartile range is. So if we visualize it, we have that first and third quartile values here, and this gives us our interquartile range, which is 10.45. Now, this is useful because, for this example at least, it's around 3 times smaller than the total spread, or the range, which, if you recall, is around 30, while still being representative of half the data, and the middle half at that. And it's interesting to see it visualized this way because we can see how it's ignoring those unusually high values close to 100. Now, there are technically 2 ways to calculate the interquartile range. The quartiles in this example are calculated by including the median, also known as the inclusive method, but Excel also lets you use the exclusive method. Now honestly, there's no right or wrong method to use. Many do prefer the inclusive method because it leads to a narrower range, but it's easy enough to calculate both and see which one you feel is the most representative, depending on the sample that you have. So let's jump to Excel now. I'm going to go to the link in the quartiles and interquartile range section. Click here. And the question this time around is, where did most graduates score in their employability tests before and after the MBA program? So the key part here is the most graduates. So we can use the quartiles to say where the middle half of the students scored and show their spread with the interquartile range. Now I also included the min and the max values to calculate here. These can also be known as the 0 and 4th quartile. And all of this, from the min to the first quartile, the median, the third, and the max, is known as the 5-number summary. So let's go ahead and calculate these. I'm going to go with the min. Then we can use the quartile function. You'll see that we have the exclusive and the inclusive. Let me start with the exclusive. Got that. We want the first quartile. You'll see that we get a value of 181. And if we change this to inclusive, then we get 181.5. So extremely similar. Since this is higher, technically our interquartile range is going to be a little bit smaller. Now let's calculate our median. The inclusive quartile. For the third quartile, the max, and then the interquartile range is going to be Q3 minus Q1. Now let's just copy all of this, drag it to the right, and we get our values for the after range. So where did most graduates score? Well, we know from the min and the max values and the range that we calculated in the previous lecture that the total spread in both is very similar and actually pretty big. I mean, these tests go from 0 to 500, so overall we are getting scores all over the place. But if we focus on where most students score, so in these quartiles here, then before the program they were getting scores between 181 and 287, with a total spread of 100 between them. But after the program, most of the students, or the middle half of the students, were actually getting higher scores between 228 and 348, which is quite the improvement, even though the range is a little bit bigger at 120 compared to 105. Now, I added this dynamic array section here because there is a really cool way to calculate the 5-number summary by using the sequence function, which is one of the new dynamic array functions. So I'm going to actually use the quartile function, and I have to be careful to use the inclusive function, otherwise this will return an error. I'm going to select my range of values. And for the quartile, you'll see that 0 is the minimum, 1 is the first, 2 is the median, third, and max. So what we can do is actually use the sequence function to generate this sequence of numbers. So 0, 1, 2, 3, and 4. So let's write our sequence function. We want a total of 5 rows. It's a 5-number summary. We don't need to add any columns. The start is going to be 0, and the step is going to be 1, because we want to go from 0 to 1 to 2 to 3, and then to 4. So I can close my sequence function, close my quartile function, and watch this. We get the same exact results, but in a single formula. So I can apply this to the right, and we've got our second 5-number summary. Now we can go ahead and calculate this as well if we wanted to. And in fact, we can do it like this. Press enter, and there you have it. Alright, so in the same way that histograms are used to visualize frequency distributions, box and whisker plots are used to visualize some of the key descriptive statistics that we've covered so far, like the 5-number summary. So if we take this sample of 16 undergrad grades and visualize them in a box and whisker plot, then we'd get something like this. It's a box with some whiskers. Now you'll notice that the box has a line that splits it in two. The bottom of the box represents the first quartile, the top represents the third quartile, and that line in the middle is the median, which means that the entire box represents the interquartile range, so we know that inside this box we have the middle half of all the values. Now the whiskers represent the min and the max, but this actually excludes outliers. So in reality, it's the highest and lowest values that aren't considered an outlier. So what is an outlier? Well, it's values like this one right here, which are at least 1.5 interquartile ranges away from the box. and the final value that it shows is represented by this x, which is just the mean. And you can see it's slightly higher than the median in this case, as it's probably influenced by that high value in the outlier. So just like the histogram, this is a really important visual tool that helps you understand the distribution, the central tendency, and the variability of your variable at a glance, which makes it very useful to quickly compare statistical characteristics between different categories. So say we wanted to compare the grades by undergrad degrees across the entire sample, well, we could then do something like this, where we can see that the top 50% of the business students tend to do better than all the rest, and we have a standout business student that has a perfect grade of 100, and we can also see that engineering students tend to get the lowest grades overall. Alright, enough talk though. Let's go to our Excel workbook and do some of these ourselves. So let's go to the Box and Whisker Plots tab, click on the link, and you'll see that we have the same question as last time. So where did most graduates score in their employability tests before and after the MBA program? So no need to do any calculations here. Let's just select our data and go to Insert. And in the same drop down as our histogram, you'll find the Box and Whisker plot. Let's align this right here. Make it a little bit bigger. And before we interpret it, let me just add some formatting. I'm going to remove the title, remove this one that doesn't really add anything. I'm going to change this from 0 to 500 since we can't get any scores above that. Let me bring this right here. So we want 0 to 500. Maybe add some tick marks on the outside here. I'm going to change the fill on these so that it's not as saturated. Let's go solid. I'm going to stick with the orange, but maybe add some transparency of like, I don't know, 70%. Let's do the same here. Stick with the blue and 70%. And I'm going to reduce the gap width here as well so that this is closer to the edges of my chart here. Let's remove the border around the chart. And you'll see that if you want to, you can show the inner point. So these are all the values that we're plotting. And you can change the quartile calculation from inclusive to exclusive. Let's stick with the inclusive since that's what we've been using so far. You'll see that it got narrower. Let's do the same here. Oh, now let's just add some helpful labels. So let's add the vertical axis title. These are employability scores. I think I spelled that right, maybe not. And let's add a legend so that we know that this is the employability before and this is the employability after. All right, so enough of that formatting. What does this tell us? Well, I don't know about you, but to me, it's more clear than ever before that employability scores are actually improving after the program. We basically have the same exact distribution almost, but shifted up towards higher scores. Time for another key lecture on variance, and most importantly, standard deviation. Now, the standard deviation gets a bad rep, in my opinion, for being this mysterious and complicated number that is really difficult to interpret. But I'm here to tell you that it's actually pretty intuitive and extremely useful if you give it a chance. Ultimately though, the standard deviation measures, on average, how far each value in your sample lies from the mean. That's it. Which means that the higher the standard deviation, the wider a distribution is, or the farther away the values are from the mean. And vice versa, the lower the standard deviation, then the narrower the distribution. Now let's look at a quick example here. These are the undergrad grades for business undergrads plotted around their mean, which seems to be around 76. Now, as you can see, some of these values or points are really close to the mean, about 1 or 2 grade points away. Some are a little farther away than that, and some are as far as about 25 points away in the case of the highest value. But if we want to know how far away they are on average though, well then we calculate the standard deviation, which in this case is 8.17. So if we were to guess that the grade of a random business student is 76, which is the mean, then we're only going to be off by 8.17 on average. Now, if we go through the same exercise for engineering undergrads, you'll see right off the bat that the points are all closer to the mean, which is why we have a smaller standard deviation. Now, the variance is simply the square of the standard deviation. And what this means is that since its units are going to be on a larger scale than the variable that it's based on, it's not going to be as intuitive, or intuitive at all really, to interpret. So if you look at the same example here, where we used to have a standard deviation of 8.17, or we do, well, the variance is going to be 66.82. So now you're probably thinking, well, that number doesn't provide nearly as much context as the standard deviation, so why should I care about the variance? And that's a good question. Most of the time, to be honest, you shouldn't bother, but the variance does have its place in some statistical tests. We're actually going to see some of those in this course, so it shouldn't be discarded. But as a single numerical measure of a variable's dispersion or spread around the mean, then the standard deviation is certainly much more effective. And to show you an example of that, let's jump to Excel really quick. Alright, so I'm going to go to the link on the variance and standard deviation. Now, before I read this question, remember that in the last few lectures we've established that employability scores after the MBA program tend to be higher than the scores before the program. And if you don't remember, we can just look at the box and whisker plot that we did in the last lecture. So the logical next question is, on average, how much the improvements in employability scores after the program actually vary from student to student. So the first thing we need to do is actually calculate the improvement for each individual student. And to do that, we're going to take the employability score after the program and subtract the employability before. It's important to do it in this order because that subtraction is going to get us the improvement from here to here. Let's apply that to the rest of our students. And now let's calculate the mean of this improvement so that we have a point of reference to use for the variance and the standard deviation. So the average of these improvements is going to be equal to 49, which tells us that students improve their scores on average by about 50. But how much does this number vary? That's the question we want to answer here. Well, let's start by calculating the variance. And there's an Excel function for that. We actually have two. One that calculates the variance based on the entire population, and one that estimates it based on a sample. Now remember that the population is all of the items that we're interested in. And in the context of our project, we're not just interested in the students from the first graduate class, we're interested in them and all of our future students instead. That's our entire population. So here we want to calculate the variance for the sample. Let's select our employability improvement. And we get a value of 879, which is just completely meaningless to me. Why? Because there's no frame of reference to interpret this number. 879 what? Well, now let's calculate the standard deviation. So we could take the square root of this number, or we can use the standard deviation function of a sample, grab our data, and we'll arrive at the same number, which makes a lot more sense. So students improve their scores by about 50, but this number varies on average by about 30. So what does this tell me? How can I use this number? Well, for one, it wouldn't be surprising if a student doesn't improve their score at all. Think about it. My best guess about their improvement is 50. But that number is going to be wrong by 30 on average. So being wrong by 50, which would mean that they didn't improve, isn't outrageous at all. That said, it would be extremely surprising if a student suddenly improved their score by something like 200 points after the program, because that's way higher than 50 compared to the average difference. And of course, when I say 50, I'm just rounding up from this 49 right here. But it's that sort of intuition that makes the standard deviation so useful and so important. Now, don't worry if you didn't fully grasp this concept. It's the first time we've really talked about it, and it's going to be a topic that we will continue to cover throughout the course. But that's the standard deviation for you in a nutshell. I hope you're excited because this is the final topic of our descriptive statistics section, and it's going to be a quick pro tip on the coefficient of variation. Now, the coefficient of variation measures the standard deviation relative to the mean, which means that it is used to compare the standard deviations of variables with significantly different means. And it sounds more complicated than it actually is, so let's look at an example. Let's say that we want to compare the variability of these two variables. Alright, well let's start by calculating the standard deviation for each one. We get a value of 7.42 for the undergrad grade and a value of 85.94 for the employability. And if we look at them like this in isolation, then we might make the mistake of thinking that the employability shows around 10 times more variation than the undergrad grade. But that's not actually the case, and if we show the mean for each variable as well, then it's a little easier to see why. Employability scores are simply on a larger scale. So to put both of these variables or both of these variabilities on the same scale, then we calculate the coefficient of variation, which simply just divides the standard deviation by the mean. And if we do, we're going to get this. Now, in this case, it actually does look like the employability variable has a higher coefficient of variation, but that difference in variability isn't nearly as much as we originally thought. On average, undergrad grades differ from the mean by around 10% of the mean's value, so 7 relative to 74, while the employability scores differ by around 35% of the mean's value, so 85 relative to 239. So that's what the coefficient of variation is all about. Now let's just jump to Excel and see another scenario just like this one to really solidify the understanding. I'm going to jump to the link on the coefficient of variation. And in this case, we want to check what varies more on average for our graduates. Is it the final grade averages, or the MBA grade? Or is it the employability scores, or in this case, the variable is called employability after. So to calculate that, we need the coefficient of variation to make the accurate comparisons. So let's start by calculating the standard deviation. I'm going to do MBA grade first. Let's do the average. And for the coefficient, we simply grab the standard deviation, divide by the mean, and we get a coefficient of 0.7. And if we grab these and apply them to the right, then you'll see that we get a coefficient of variation of 0.32 for the employability. So if we compare these, then it does look like there is more volatility around the employability scores, which is going to make them harder to estimate in comparison. Time for an assignment on the measures of variability. Now, Molly got back to us once again after our last assignment, and now she's wondering, if it looks like it's the business undergrads in our program that are getting the uncommonly high scores, could it be that their grades are just more dispersed altogether? Because I would hate to make a wrong assumption here. And it would help if you could provide some sort of visual as well, especially if I'm going to end up taking this to the board. So let's summarize this into a pair of key objectives. Number 1, calculate the range, interquartile range, and standard deviation for the MBA grade variable by undergrad degree. And 2, compare the MBA grade by undergrad degree using a box plot. Again, all with the purpose of checking if the business undergrads have more dispersion in their MBA grades compared to the other undergrads. So take your time to go through these steps and think about the interpretation of your results before you move on to the solution video.